Our next contestant today is Daniela Vargas Trujillo with the Department of Chemistry in the College of Science. The title of the presentation today is The Road Toward Discovering Better Metals.
Did you know that an ounce of palladium and platinum costs almost $1,000, whereas an ounce of nickel is only 50 cents? Crazy, right? But why do we care? Well, precious metals like palladium and platinum are very important. And even though we don't see them, they're all around us. We find them in cars, electronics, we use them to make medicines and to make synthetic materials. The reason why these metals are so expensive comes down to availability. These metals are very hard to find, and we only find them in small quantities in very specific locations, making things around us a bit more expensive than they should. And if we think about it, as time goes on, it's just going to be harder and harder to find these metals, making things more and more expensive. So better alternatives are needed. Base metals like copper, zinc, nickel, and iron are a lot cheaper, and we find them in very large quantities. So why don't we use these metals already? Well, it's a bit more complicated than we think. These cheap metals do not have some of the great properties that the expensive metals have, making them not very useful. But if we combine some small molecules to these cheap metals, we can make them behave more like the expensive ones. And that is when my research comes into play. By studying a cheap nickel compound, I was seeing how different molecules affected its properties while comparing it to the neighbors of palladium and platinum. For instance, one small molecule may help this nickel behave more like the expensive metals, whereas a different molecule may do the exact opposite. While doing this, I realized that the number of small molecules that could be attached to these cheap metals are just way too many. So it would be just impossible to study them all in the lab. And that is when artificial intelligence came to my help. Calculations that could take days or even weeks could be done in just a couple of seconds. So, by using a relatively small number of results I obtained in the lab through experiments and computer calculations, artificial intelligence generated a large number of data that told me a bit more about the properties of these compounds, which ones could be useful and could exist in real life. By the end, I had a list of about 5,000 compounds, and out of these, only about 200 were going to be useful. So now, we can go back to the lab and start testing them. And instead of spending a lot of time, money, and resources by testing a very large number of compounds, we start with a small set of 200 we find. This is only a small stepping stone on the long road of finding better metals. But hopefully, one day, we're going to find the perfect combination between a cheap metal and small molecules that could help us replace the more expensive metals, making things like medicines and electronics cheaper and more affordable for everyone. Thank you.